So Assalamualaikum and hi, my name is Alif and I will begin with the introduction. So now let's start with the brief history of laptops. So in the early 1980s, laptops were very heavy and weighed in about 24 pounds and had a limited battery life. And in contrast, modern laptops are much lighter, more powerful and energy efficient. And today they weigh around 1.5 to 3.5 pounds and comes with the long-lasting batteries. And now let's take a look at the key components of laptops. This includes the battery, which powers the device, and the processor, which performs the calculations, and the screen that displays the information, and also the cooling fan that prevents overheating. Let's talk about the significance of laptops and why they are important in our daily life. So first, laptops are widely used for communications, education and work, making them essential tools for students, professionals and even casual users. So secondly, let's connect this to the electricity and magnetism. Electricity enables laptops to function well, process data and display information. Meanwhile, the magnetic principle allows sound productions in speaker and support data storage in hard drives or other devices. And finally, laptops have advanced significantly over time, making them much faster, thinner and more energy efficient, which improves the portability and reduces energy usage. And by these improvements, it makes laptops more practical and environmentally friendly in everyday life.
For relevant electricity and magnetism concepts, there are three groups, which is electric currents and circuits. Electric current refers to the flow of electric charge through conductor. In a laptop, current flows through a complex network of circuits on the motherboard, allowing electrical energy to be delivered to different components such as CPU, memory, and storage devices. Next, Ohm's law. V equal to IR. Ohm's law explains the relationship between voltage, current, and resistance. In laptop circuits, this law is important to control the amount of current flowing through components so that they operate safely without overheating or damage. Lastly, capacitance. Capacitance is the ability of a component to store electrical charge. Capacitors in laptop temporarily store energy and release it when needed to maintain a stable voltage supply to sensitive electronic components. A real-world example of this implementation of concepts is motherboard circuits. The motherboard contains printed circuit boards that allow electric current to flow efficiently between different components. These circuits ensure that electrical energy is distributed correctly throughout the laptop. Next is cooling fan. The cooling fan functions as an electric motor. When current flows through the motor coil, a magnetic field is produced, causing the fan blades to rotate and remove excess heat from the laptop. Lastly, CPU and GPU. The CPU and GPU contains billions of transistors made from semiconductor materials. These transistors use electric fields to control the current flow, enabling high-speed data processing and computation.
Moving on to our next slide, let's discuss why laptops have become such an essential tool in our daily life. We have broken down the benefit into three main categories: portability, connectivity, and easy access to information. First and foremost is portability. Unlike a traditional desktop setup, a laptop is lightweight and designed to be carried anywhere, whether that's to a classroom, library, or back home. This flexibility allows us to learn and work from any environment, which is perfect for anyone living a modern, flexible lifestyle. Secondly, laptops excel at connectivity. They allow us to jump onto Wi-Fi network instantly and connect to external devices like projector for presentation. Beyond hardware, laptops are the gateway to collaboration. They support online meetings and group discussion, making it easy to work with teammates across different locations in real time. Finally, there is the easy access to information. With a laptop, the word knowledge is at your fingertip. It allows users to research for information quickly and provide instant access to news, educational platforms, and online resources. It essentially turns any space into a research hub. Moving on, while laptops are incredible tools for productivity and learning, they do come with their own set of hurdles. It's important to recognize these challenges so we can manage them effectively. We have identified four main areas: cost, battery life, health, and distraction. First, we have the high cost of entry. For students or professionals needing to run specific program, a basic model often would not cut it. Good quality laptops with high performance are expensive. Beyond the initial purchase, we also have to consider the long-term investment, as repair and specialized spare parts can significantly increase the total cost of ownership over time. Second is battery limitation. The portability of a laptop is the best feature, but then depends entirely on the battery. We find that the battery drains much faster when running heavy software like video editor or games, leading to a constant need for frequent charging. Furthermore, battery performance naturally decreases over time. Third, and perhaps most importantly, are the health issues. Spending long hours in front of a screen can lead to digital eye strain and frequent headaches. Additionally, because laptops encourage us to sit in various, often non-ergonomic locations, poor posture is common, which can lead to chronic back and neck pain. Finally, there is the challenges of distraction. A laptop is a gateway to the entire internet, providing easy access to social media and games at the click of a button. This can significantly reduce focus during lecture or dedicate study time. If not managed well, the very tool meant to boost our productivity can actually end up hindering it.
So, let's move on to my part. I'm going to talk about future development and innovation in laptops. Basically, I show you how the laptops we use every day are about to become much smarter, faster, and cooler. Firstly, energy efficiency and battery technology. First, let's talk about batteries. Right now, our laptops die too fast. In the future, we will use solid-state and graphene batteries. These are just better versions of what we have now. They are safer, lighter, and charge up in only a few minutes. Also, with energy harvesting, your laptop could actually charge itself a little bit just from the light in the room or the Wi-Fi signal around us. Second, magneticism and cooling innovation. This is how we keep laptops from getting too hot. Instead of loud fans that break easily, we are going to use magnet. We can make fans that float on magnet so they are totally silent. We are also using special material that get cool when they touch a magnet field. This means laptop can stay very thin and quiet without ever overheating. Thirdly, integration of smart sensor and Internet of Things. We are also making laptops much more aware of their environment. By using smart sensor, your laptop can handle security like Face ID or fingerprints instantly without killing our battery. This sensor can also detect things like the air quality or the lighting in your room and automatically adjust the screen to make it easier on your eyes. Moreover, the laptop becomes a hub that stays perfectly scanned with your phone and smart device the moment you open it up. Lastly, improve connectivity and performance. Finally, we have the brain and the speed of the machine. With 6G technology, downloading massive files will be almost instant. Inside the laptop, we are adding special AI chip that act like a smart manager. This AI watches what you are doing. For example, if you're browsing the web, it saves energy. But if you start a heavy task like video editing, it boosts the power immediately.
It's all about giving us the best performance exactly when we need it without wasting battery life.
In conclusion, the advancements of laptops shows a clear practical example of how electricity and magnetism work together. So the electric energy allows laptops to operate, while the magnetic effect supports the sound productions, data storage, and cooling. This demonstrates that the electricity and magnetism we learn in class are not just a theory, they are applied in real-life technology that we use every day.